Welcome to Weekend Academy YouTube channel. Today now in chemistry we are going to discuss Lewis structures. How to draw Lewis structure for a given molecule or ion. We use certain steps here. We are going to discuss in detail. At the end of this video, we will be in a position to write correct Lewis structure without any difficulty for any ion or a molecule. Let us start. For that, we use certain steps. The first one, add all the valence electron. Suppose the molecule is carbon dioxide, we will have to add all the valence electrons of the carbon dioxide molecule. Say carbon has 4, oxygen has 6, 2 oxygen atom, 6 into 2, 12, altogether 16 electrons are there. 16 electrons are there in a molecule of carbon dioxide. Okay, in the same way, nitrogen molecule 5 plus 5, 10 electrons are there. A cyanide ion, carbon 4 electron, nitrogen 5 electron. Due to the minus 1 charge, 1 more electron, altogether 10 electrons are there in a ion Cn minus. Carbon dioxide, how do we represent? For that, the second step is identify the single atom present in the molecule, then we take it as the central atom. Say carbon dioxide, carbon, oxygen, oxygen 2, carbon only 1. So carbon is considered to be the central atom of the molecule C. And then we write on either side 2 oxygen atom. Total number of electrons here, 16 electrons are there. So we will have to distribute those 16 electrons among all these 3 atoms, say oxygen, carbon and oxygen, in such a way all the 3 atoms will have to get 8 electrons each. That is called octet rule. See, this is the arrangement here. A pair of electron here, one pair of electron here, and 2 pairs in between carbon and oxygen. Okay, the same way on the other side also, 2 pairs outside, 2 pairs between the carbon and oxygen. If we encircle here, oxygen now get 8 electron, 4 plus 2 plus 2, 8 electron. Here this side, 2, 4, 2, 8 electron for oxygen. Now in the center carbon, 4 plus 4, 8 electrons. Thereby, all the 3 atoms get 8 electrons each. This is how they get the satisfied electronic structure, Lewis structure. It is a linear molecule. We shall see some more examples one by one. Next, we see a group of molecules made of 2 atoms only. They are called diatomic molecules. Here, the first example here of this type is oxygen. Oxygen atom has 6 electrons in the valence shell. 2 oxygen atom, O2, what does it do? There are 12 electrons. So those 12 electrons have to be distributed between the two. See here, 4 electrons in the middle and 4 electrons this side, 4 electrons this side. Now you see, oxygen has 8 electron. This oxygen has 8 electron, and this can be represented as this. This is a Lewis electron dot structure for oxygen molecule. Here 12 electrons we have seen. No, another molecule, nitrogen, it has 5 plus 5, 10 electrons. Those 10 electrons have to be distributed in such a way both the nitrogen atom will have 8 electron each. For that, what do? We keep 3 pairs of electron in between the 2 nitrogen atom and 1 pair outside, 1 pair this side. See, so 3 pairs make 3 covalent bond. 1 lone pair this side, 1 lone pair this side. Now we can see 6 plus 2, 8 electron for this nitrogen, 6 plus 2, 8 nitrogen for the other hydrogen. This is how both the nitrogen atoms in the molecule of nitrogen acquire 8 electron octet satisfied electronic configuration. This leads to the formation of N2 molecule with a triple bond. Now another example, fluorine. Fluorine F2. Here in the F2, there are 7 plus 7, 14 electrons here. What do they do for this? Keep a pair of electrons between the 2 fluorine atoms making a single covalent bond. And the remaining 12 electrons, 6 electrons, 3 pair here, 3 pair this side. This is how F dash F. F covalent bond F. This is the glue structure for simple fluorine molecule. The next we have carbon monoxide CO. Here carbon valency 4 electrons, oxygen valence electron 6. Altogether there are 10 electrons. Already we have seen in the nitrogen molecule 10 electron. Same structure has to be written here also. Carbon monoxide and N2 are having 10 electrons each in their valence shell. That's why nitrogen triple bond. Here oxygen, carbon oxygen triple bond. Here also one lone pair. Here also the same, similar. And the next, nitric oxide. Nitric oxide formula is simply NO. This nitric oxide, nitrogen has valence electron 5, oxygen valence electron 6, altogether 11 electrons are there. Similar one, but 11 electrons have to be distributed in such a way oxygen gets 8 electrons, 1 pair, 2 pair, 2 pairs in between. Totally 8 electrons for oxygen. Nitrogen 4 pairs, 2 pair, but 1 electron is left. It requires one more electron, only then this structure is possible. However, nitrogen having only 7 electrons actually. Nitrogen has only 7 electron in this structure, whereas oxygen 8 electron. So, one more thing to see here, odd electron. Instead of a paired piece, it is nitrogen has only 1 electron odd separately. So now NO molecule is highly reactive due to the presence of single odd electron. This is an odd electron species or free radical unstable compound, quite reactive. Okay, electron deficient molecule. Now HCl, hydrogen has 1 electron, chlorine has 7 electron, altogether only 8 electrons are there. What does it do? Keep 3 pairs of electron outside, 1 pair in between hydrogen and chlorine, and thereby HCl single covalent bond with 3 lone pairs of electron on chlorine. Next, triatomic molecules. Molecules having 3 atoms. Carbon dioxide, which we have already discussed. Nitrogen dioxide, NO2. Here NO2, nitrogen 5 electron, 2 oxygen 12 electron, 5 plus 12, 17 electron. The 17 electron, here what does it do? Singly bonded oxygen atom with 3 lone pairs of electron, doubly bonded oxygen atom having 2 lone pairs of electron. See arrangement. 4 plus 2, 6 plus 2, 8. This oxygen receives 8 electrons. This oxygen also 2, 2, 2, 4 pairs, 8 electron. But what about the nitrogen? Nitrogen 4 plus 2, 6 plus 1, 7 electron again. It is short of 1 electron. Nitrogen dioxide also, just like nitric oxide, a free radical having odd electron deficient molecule. That's why nitrogen dioxide highly reactive. It actually dimerizes. It reacts with one more molecule and make a pairing effect here. Next, sulfur dioxide. Sulfur dioxide 1, 2, 3. All the 3 atoms have 6 electrons in their valence shell. Totally 18 electrons. Those 18 electrons, the same thing. Here single electron, here double electron, nothing else. Exactly same structure. Singly bonded oxygen with 3 lone pair, doubly bonded oxygen having 2 lone pair, and sulfur has 1 lone pair. Same. All are 8 electrons having 8. Similar, there is one more molecule, ozone, O3. The same way 18 electrons are here, exactly same as that of sulfur dioxide. No difference. Next, anions. We have been seeing only molecules. This time or negative ion we are going to discuss here. Carbonate, CO3 2 minus anion. carbon 4 electron, oxygen 3 into 6, 18 electron, 2 minus charges 2 electron. Altogether 24 electrons are there. These 24 electrons distributed in such a way, two singly bonded oxygen atoms, whereas doubly bonded oxygen one. Doubly bonded means no, two lone pair, single three lone pair. Due to the extra electron, this is minus, this will also carry minus. So this is the structure. Here oxygen has 8 electron. How? 2 2 4 8 electron. 2 2 6 plus 2 8 electron. Here also 6 plus 2 8 electron. For carbon, 1 2 3 4 4 covalent bond. Each bond carries 2 electrons, altogether 8 electrons. Thus, all the 3 atoms acquire stable 8 electron structure. Next example, sulfite ion. Sulfite SO3 2 minus. SO3 2 minus sulfur 6 electron, 3 oxygen atom, 18 electron, 18 and 2 minus, then we have 26. 24 plus 2, 26 electrons are there. 26 electrons, a similar category, but here 8 electron octet structure, singly bonded oxygen, just like this, same way. Here extra one pair of electron for sulfur. Carbonate and sulfide, the difference is only one difference. Exactly same. Here 24 electrons, here 26 electron. This extra 2 electrons stands as lone pair for sulfur. Otherwise, exactly one and the same. Okay, now sulfate SO4 2 minus. SO4 2 minus 1, 2, 3, 4, 5. All are 6 electron species. 30. 6 into 5, 30 plus 2 minus charges 2. 30 plus 2, 32 electrons. It has 32 electrons. 2 oxygen atom single bonded. 2 oxygen atom doubly bonded. Doubly bonded, no, double bonded here 2 lone pairs here 3 lone pairs. So now all the oxygen atoms get 8 electrons each. There is no problem. But for sulfur, 2, 4, 5, 6 covalent bonds. 6 covalent bonds means no, there are 12 electrons in the valence shell of. Here also 1, 2, 3, 4, 8 plus 2. Here 10 electrons. In all the previous cases, an atom acquire 8 electrons in the outermost shell, nothing more than that. But here in these two cases, what happens here? Sulfur has in the valence shell 10 electrons. See, one bond, 2, 3, 4 bonds. 4 into 2, 8. Here one lone pair, 10 electrons are there. It means 2 electrons extra. Here 4 electrons extra. How many bonds? 1, 2, 3, 4, 5, 6 bonds, 12 electron. But oxygen has 8 electron, carbon has 8 electron, nitrogen, in all the cases we saw only 8 electrons in the valence shell. But here in these two cases alone, sulfur gets extra electron. This is extended valence shell. Extended, it can expand its valence shell by accepting some more electron, because this sulfur belongs to third period in the periodic table. The third period we have 3s2, 3p6 and 3d also is there. The 3d shell is there. Whereas in the carbon and all 2s, 2p, no 2d. That's why a vacant 3d subshell is available. D orbitals are available. There it can accommodate those 4 electrons. That capability is there for sulfur since it belongs to the third period. Okay. Next, we have one more example, cyanide, Cn minus. How many valence electrons are there? Carbon 4 electron, nitrogen 5 electron, 1 minus charge. Altogether, there are 10 electrons. We have already come across a molecule with 10 electrons in the valence shell. What do they do there? See, triple bond N, here one lone pair, there one lone pair, which we have seen there in case of carbon monoxide nitrogen molecule. In all the cases, CON2. In those two cases also 10 electron. There we saw a triple bonded C, triple bond N, but there is a minus charge here with a lone pair of electron here, lone pair of electron here. So this is the cyanide minus. And finally, we have come to another anion, phosphate ion, PO4 3 minus, phosphorus 5 electron, 4 oxygen atom 24 electrons, 3 minus charges 3 electron, then we have 32 electrons. Just like SO4 2 minus ion. Phosphorus, this is phosphorus at the center, and this is oxygen. Singly bonded oxygen, 3 lone pairs. Doubly bonded oxygen, two lone pair. Exactly same way. Phosphorus, here you see 2, 4, 4, 8 electron for this oxygen. 4 pairs, 8 electrons for this oxygen. 4 pairs, 8 electrons. 4 pairs, 8 electrons. So all the 4 oxygen atoms acquire 8 electrons. But however, this is a single bonded, double bonded, single bond. All the single bonders have one minus charge. You know the reason, because of the extra electron. But what about the phosphorus? Phosphorus now has 4 to 6 plus 2, 8 plus 2, 10. 10 electrons are there. When all the atoms in the molecule receives 8 electrons, this has 2 electrons extra. How can it accommodate those 2 electrons? Again, the same reason. Nitrogen 2s 2p, but whereas phosphorus 3s 3p 3d, there is a vacant d orbital where it can accommodate those 2 extra electrons. It is expanded or extended valency shell. That's why phosphorus gets 10 electron. And this is the structure formula. This is dot formula. This is how we are writing phosphate 3 minus anion. With that, we are concluding the Lewis structure for different molecules and ions. I hope you will understand and do it well. In the another video, some other video, I will come and meet you with an important topic and discuss there more. Thank you.